Solve It Simple, your academic companion to master math the smart and simple way. In this video, we are going to learn about irrational numbers and how to plot these numbers on a number line. We are also going to learn to solve the second exercise of chapter 1, that is exercise 1.2. So if you are ready, let's get started. Remember, solve it easy, solve it cool and solve it simple. In this video, let's learn about irrational numbers. What is the definition of an irrational number? A number S is called irrational if it cannot be written in the form of P by Q, where P and Q are integers and Q is not equal to 0. So any number is called irrational if it cannot be written in the form of P by Q. So this makes us think about what rational numbers are. We know that a number R can be written as R is said to be rational if it can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. That means any rational number like 1 by 2, 2 by 5, etc. Even whole numbers, even 0 can be is a rational number because 0 can be represented as 0 by 1. So these are rational numbers. So what could be irrational numbers? Examples for irrational numbers would be a number cannot be expressed in the form of. So that means examples are pi, root 2, root 3, etc. Remember, this root represents the square root of a number. So any number if cannot be represented in the form of P by Q, they are called irrational numbers. So now we will see that both rational and irrational numbers together forms a real number. Now we know what rational and irrational numbers are. So we can say that the collection of all these rational and irrational numbers together form real numbers. So real numbers are the collection of rational and irrational numbers. And we can say that every real number has a unique point on the number line. So we have a number line, be it rational or irrational. Every real number has a unique point on the number line. For example, 1 and 2 are rational numbers. We can be represented this in the number line 1 and 2, or in a rational number root 2. We will see now how it represents root 2 on a number line. That is also a real number. We can be represented on a number line. Now let's learn to locate an irrational number on a number line. For example, locate root 2, which is an irrational number, on a number line. To do that, let's refresh what Pythagoras theorem is, what you have learned in your previous class. What is Pythagoras theorem? For that, consider a right triangle OAB. What Pythagoras theorem states that if you have a right triangle, if you have a base and an altitude, 1 unit each, what is the hypotenuse? Hypotenuse OB is equal to square root of OA square plus AB square. OA is the base, AB is the altitude. So it is, if you have a unit length right triangle, OA is 1 square plus 1 square, which is equal to 1 plus 1, which is root 2. So if you can transfer this right triangle into our number line, considering O as the 0 of the number line, let's draw a right triangle here with OA or 1 as the base and 1, consider this is 1 as the altitude, and you have this as the hypotenuse. So what would be this value? This is 1 unit, this is 1 unit, this is OA and this is B. So this value will be root 2 because OB is root 2. So if you can consider a right triangle, or this is 1 unit in the number line and this is also 1 unit, this is root 2. So if you take a compass and you measure this as the radius, keeping this as the origin and this as the radius, you just mark intersects this radius onto the number line. So I'm using a pencil here because I cannot, you won't be able to see that because I'm using a pencil to draw it on the board. So this is the arc. Use a compass, you draw the arc cutting the number line. Mark it as point P. This will be the value. So root 2, you are extending it to the number line. This value will be root 2. This is how you locate or you plot root 2 on a number line, which will be between 1 and 2, right? Let's start solving the second exercise of chapter 1, that is exercise 1.2. Let's read the first question. State whether the following statements are true or false. Justify your answers. The first question. Every irrational number is a real number. What do you think? Is every rational number a real number? What do you mean by a real number? We know real numbers are a collection of both irrational and rational number. So that means every irrational number is a real number. So the answer is, the answer to this statement is true. Every rational number is a real number. And the reason is real numbers are a collection of rational and irrational numbers. Collection of rational and irrational numbers. So every irrational number is a real number. Let's solve the second question. Let's read the question. Every point on the number line is of the form root m, where m is a natural number. Every point on the number line is of the form root m, where m is a natural number. Do you think this statement, what do you think? Is the statement true or false? Can you represent every number as root m, where m is a natural number? What about negative numbers? Can you represent root of -1 on the number line? No. So the statement is false. Reason behind is every negative numbers cannot be expressed as the square root of any natural number, because we cannot represent every negative number as the root. So the statement is false. Every negative number cannot be expressed as a square root of any natural numbers. Of any natural number. So the statement is false. Third question, let's read the question. Every real number is an irrational number. Do you think every real number is an irrational number? This is an easy one, right? Because every real number is not an irrational number. The statement is false. Why? Because real numbers consist of both rational and irrational numbers, not only irrational number. So the reason is real number consist of rational and irrational numbers, not only irrational number. So every irrational number is a real number, but every real number is not an irrational number. Hope it's clear to you. Let's read the second question. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. The question is, are the square roots of all positive integers irrational? And if it is not, give an example of the square root of a number that is a rational number. Do you think all square roots of positive integers are irrational? No. why the statement is false, the square root, or you see. And now state the reason why it is false. Can you say an example? Consider root 4. 4 is a positive integer and is also a perfect square. So root 4 is 2, which is a rational number. So the example for the statement, what we said, the square roots of all positive integers are not irrational. It can be rational also. Examples are root 4 is 2, which is a rational number. 2 is a, you can write 2 is a rational number. Can you find another example for this statement? What about root 9? Root 9 is 3, so that is also a rational number. Again, root 16, which is, the answer is 4, so that is also a rational number. So you can write any one example for this answer. Let's solve the third question now. Let's read the question first. Show that root 5 can be represented on the number line. You have to locate irrational number root 5 on the number line. You have learned that to locate any root n of any positive integer, n, if you have to locate any positive integer, say n, you have to first find the root of n minus 1 to locate the number. So if you have root 5, to locate root 5, you have to find root of 5 minus 1, which is root 4. What is root 4? It is 2. If you can locate root 2 on, locate 2 on the number line, you know it's easy to locate 2 on the number line. This is a rational number. You draw 2 and root 5 will be after 2. Now let's locate root 5. Before that, let's revise what Pythagoras theorem is. By Pythagoras theorem, you know if you have a right triangle, consider a right triangle OBC. You know OC is the hypotenuse, OB is the base, and BC is the altitude. We know hypotenuse square OC square is equal to OB square plus BC square. That is, hypotenuse square is equal to base square plus altitude. Or we can write OC is equal to square root of OB square plus BC square. We use the concepts of Pythagoras theorem to locate root 5. If you can find that this is root 5, you can easily locate that on the number line. So what can be done here? So if to find root 5, can I make this as, let's consider this right triangle OBC where we have base as 2 units and the altitude as 1. So let's redraw that so that it will look like a 2 unit right triangle. So if you have 2 units here and 1 unit here, OCB. So you have 1 unit here for the altitude and 2 units base. We can easily say that what is OC? OC will be square root of 2 square plus 1 square. OB is 2 and BC is 1, which will give you square root of 4 plus 1, which will give you root 5. So from this you can find out easily that OC is root 5. So if we can use the same concepts on the number line, we can easily locate root 5. Hope it's clear to you. So if you have to locate root 5, make sure you take the base as base and the altitude accordingly, so that you will get the answer as root 5. Now let's locate root 5 on the number line. I have already drawn the right triangle here so that it is easy for you to understand when I draw it on the number line. So I have drawn the number line here. Let's mark the number line. Make sure when you draw the number line, be careful when you take the scale. Here I have the number line. I have taken this 1 unit as 5 centimeter. That means 0 to 1 is 5. This is 5 centimeter each. It is very important when you take the scale. So So here for me the scale is 5 centimeter is 1 unit. So now we have to draw the triangle here, locate the root 5 here. So how will you represent the root 5? So for that we take root 0 to O to B, that is from here, from 0 you have take 2 units. So here I have measured 10 centimeter. This is 10 centimeter. So my OB will be, let's mark this as B also, OB, for you to understand. So this is the base of the triangle, and now we have BC as 1 unit. So I am measuring 5 centimeter because 5 centimeter is my 1 unit. So what will be this? This is C. This is 1 unit and this is 2 units. Okay, make sure you don't make a mistake there, 1 unit. And now join OC. What will be OC? OC is root 5. Okay, hope it's clear to you. So from 0 to 2 we have 2 units, which is our base, and this is BC, which is our altitude, and OC is the hypotenuse, which is root 5. Now take the compass with O as the center and OC or root 5 as the radius. O as the center and root 5 as the radius. Draw an arc intersecting at the number line. So root 5 is extended to the number line, and this will be our root 5. Hope it's clear to you. So draw the number line. Make sure you take the right units, 2 units here and then 1 unit to the altitude, and then join OC, which is root 5, and keeping O as a center and this as a radius, root 5 or OC as a radius. Draw the arc intersecting at the number line. The point where the arc intersects at the number line will be root 5. This is how you locate root 5 on the number line. Hope it's clear to you. Try to do it by your own, then it will be clear for you. Now if you are asked to find root 6 on the number line, how will you do that? We know if you have to find root 6, first of all you have to find root 5, because root of 6 minus 1, root 5. If the root 5 is located, root 6 can be easily located. So as we have already found root 5, let's draw from here. So what is the next procedure? Next one is we have to find the base of the new triangle. So we know if we have root 5 as, you see, we have to find root 6. Root 6 can be written as root of, here we have base as, if we take base as root 5, let's see whether we can do like that. Root 5 the whole square plus 1 square. What will be that? It will be root 5 the whole square will be 5 plus 1, which is root 6. So you can see that if you can make the base of the triangle as root 5 and the altitude again as 1, we will get root 6. So how will you do that here? We already have this as root 5, right? So 0 to point here. Let's mark this point as OC now. Let's make it as OD, so that this also will be changed to D. Clear? So root 5 or OD is root 5 is a base. And how do you do that? Now draw a line of 1 unit, or you can use the perpendicular bisector to perpendicular line, not perpendicular bisector, you can use the perpendicular line to draw that of 1 unit here. So that is 1 unit. And now join the new triangle. What will be the triangle here? Let's mark it as E. So this is E. Here it will become E as well. Okay. And now join this right triangle having base as OD as root 5, OD, and altitude as DE, and the hypotenuse. The new hypotenuse is OE. Let's mark this as well. So you have the new triangle ODE. So what is this value? This will be root 6. So now what we have to do, you have to make OE or root 6 as the radius, the new radius, and then mark it on the number line, keeping O as the center and OE or root 6 as the radius. You mark, intersect it on the number line. This will be root 6. Hope it's clear to you. So how will you find root 7 now? Again the same way. You take root 6 as the base and again 1 unit. That will give you root 7 as the hypotenuse. Pull out that, you will get root 7. Up to root 8 you can do the same way. And root 9 is 3. And any number after that, if you have to do root 10, you have to take 3 as the base and then plot it accordingly. Try doing more examples so that it will be reinforced to you. By this we have come to the end of the video. Thank you for watching till the end. Hope you have understood the concepts of irrational numbers and are able to solve the questions of exercise 1.2. Keep practicing more questions on plotting irrational numbers on the number line. In the next video, we will learn about real numbers and their decimal expansion. Also, we will solve exercise 1.3. So, see you in the next video. Till then, enjoy learning. Take care and bye.